Hello geometry students, this is Mr. Fugay, and this video we're going to talk about how to evaluate trig expressions. So we have now taken the time to learn how to evaluate a trig expression in of itself, but what if it is mixed together with multiple operations? Well, when we work with trig expressions with multiple operations, we are still going to use our trusted PEMDAS to help us with that. But there's a few notes I want to make before we try a few of these. First off, when you are evaluating this, we need to read this as a function, sine of pi over 3. We will never consider this as sine times pi over 3 because when you write sine, the immediate thing you want to write next is the angle that is being evaluated. If you know the angle, you write the angle. If you don't know the angle, you would put a variable there, and we'll talk about that in future videos. And the last thing is, when a trig expression is raised to an exponent, the exponent is actually going to be put in a different place to avoid confusion. So if you look down here, you will see that when we want to take sine of 30 degrees and square it, we can wrap it in a parenthesis. Versus this situation where we have sine and then the number 30 is actually being squared. So what I'm hoping you see here is that there are two very different situations that happen here. In this first situation, we would evaluate sine of 30, which is going to be 1/2. And then once we find that ratio, we would then square it to give us an answer of 1/4. Versus in this situation, the order of our operations tell me to take the 30 degrees and square it, giving me 900. Then we would use our coterminal work to figure out that that's actually 180, use our unit circle to get an answer of 0. As you can see, very different operations, and if you notice, the square is in the exact same spot. The parentheses is what makes it different. So this scenario right here, the green scenario, what we're actually going to do is use this notation instead. We're going to move the square symbol next to the trig ratio. What that basically means is evaluate the trig ratio first, then you square the answer. So this is common notation of what you're going to see moving forward. So with that being said, let's look at some examples. Looking at example A, the first thing I like to do in a lot of these problems is sort of build out the skeleton of the problem, meaning without the evaluation of the trig. For example, this is 3 plus, now since there's that new squared symbol we just talked about, we would evaluate sine of 90 and then square it. So if you notice, I'm leaving a blank there for us to do that. And like even for letter B, we're going to do A and B sort of together. I would do the same thing. 12 times we'll evaluate cotangent of 45, minus we'll evaluate cosecant of 30, plus, and then we would evaluate secant of 45. I like to build these in just so that I can take care of my trig thinking first and then worry about the order of operations next. So what are these answers? Well, when we're trying to figure out sine of 90, remember we would use our unit circle and know that the point 0, 1 is what's going to help lead to that answer. Sine is the y value, so that means we would put a 1 in here. And then from here, now we can turn on our order of operations and say, oh, well, we're going to square that 1, making it 1. 3 plus 1 is 4. And so the final answer for this first question would just be 1. Now, if we go to the next one, we're going to need to utilize some of our knowledge of the trig toolbox. So cotangent of 45 is the reciprocal of tangent of 45. Tangent of 45, as you know, would be just 1 over 1. So the answer for this one is 1. Cosecant of 30 is the reciprocal of sine of 30. Sine of 30 is 1 over 2. So cosecant would just be 2. And then last but not least, the secant of 45 is the reciprocal of cosine of 45. Cosine of 45 is 1 over root 2. Therefore, we would put root 2 in its place. So now we would do the order of operations. 12 times 1 is 12, minus 2, plus root 2. We can subtract the 12 minus 2 to give us 10, and so this solution would just be 10 root 2. All right, so let's move on to a couple others. There are 6 examples we're going to go over total in this video. Feel free at any point, especially moving forward with these last 4, if you want to pause and try it first, and then see what you do as I walk through it next. So in this one, let's set it up. We're going to take sine of 0 and then square it. We're then going to take tangent of 60 and then square it. And lastly, we're going to add 23 to that number. So what do we have here for this? Well, sine of 0 is just going to be at the point 1, 0. Remember that sine is our y value, so that's going to make this 0. Tangent of 60, we would use our 30, 60, 90 triangles. So there's 60. Tangent is going to be root 3. Whoops, I put that in the wrong spot. Always careful with that special right triangle now. That would be root 3 over 1, or the square root of 3. Now we can begin the order of operations. So this is 0 times root 3 plus 23. That's going to actually just cancel out, leaving me with nothing more than just 23 as my answer. Now we can also do this with radians. So here's an example using radians. We would take secant of pi over 3 and then cube it, actually, let's write that cubed, minus, and then we would take the cotangent of pi over 4 and also then cube it. So let's focus our attention just on the secant of pi over 3. That's the reciprocal of cosine of pi over 3. Remember, pi over 3 is 60 degrees. So the cosine of 60 is 1/2, which means secant is equal to 2. Cotangent of pi over 4 is the reciprocal of tangent of pi over 4, which is equal to 1. And the reciprocal of 1 is, well, 1. So now we evaluate. 2 to the third power would be 8. 1 cubed is 1. And so our final answer for this one is going to be 7. All right, let's try the final 2 questions on this example set. All right, as we continue to move forward, remember, I like to really build out the skeletons of these questions first, knowing, for example, I'm going to find secant of 0 and then square it. In this case, we'll take cotan 30, square it, and that gets multiplied to the cosecant of 60 quantity squared. All right, so what are these results going to actually give me? Same thing as before. When we talk about 0, we need to look at the unit circle at the point 1, 0. Secant is the reciprocal of cosine, and cosine is our x value. So the reciprocal of 1 is, well, 1. Cotangent of 30, we would look at our 30, 60, 90 triangle. So there's our 30. Cotangent is the reciprocal of tangent, 1 over root 3, which means it's going to just be root 3. And finally, cosecant of 60 is the reciprocal of sine of 60. Sine of 60 is root 3 over 2, and so therefore its reciprocal is 2 over root 3. Now this is a situation where you might ask, well, do I rationalize this? And I would say, let's wait and decide that after we've squared these numbers, because that will help determine whether that makes sense or not. 1 squared is just 1. Root 3 squared is just going to be 3. Let's keep that in parentheses. And then 2 over root 3 means that I'm going to take that and square each of those values, giving me the value 4 over 3. So as you can see here, rationalizing really didn't make sense because once we squared it, it got rid of the radical anyways. Order of operations next tells me to multiply 3 to 4/3, which means those 3's are actually going to cancel out, leaving me with 1 plus 4, and the final answer here is going to be 5. All right, let's try one more problem. And this one is going to have some radicals involved, and we'll talk a little bit about rationalization in this one. All right, first things first, let's find these values. So we're going to have cotangent of 60, we're going to add it to secant of 30, plus, and then we have the fraction cosecant of 45 over secant of 30. So the cotangent of 60 is the reciprocal of tangent of 60, so that gives me 1 over root 3. The secant of 30 is the reciprocal of cosine of 30, which is going to be 2 over root 3. And then we do these ones. Cosecant of 45 is going to be the square root of 2, and the secant of 30 is going to be the complex fraction, yes, 2 over root 3. All right, so we've got a lot to talk about here. We actually really 2 different things we need to discuss. The first of which is over here on the left-hand side, and that's the fact that we can actually add these 2 things together immediately, and that is because they have a common denominator. If they did not, this would be then a place where I would probably recommend to rationalize, but since they're already got a common denominator, I can simply just add the numerators and say that this is going to be 3 over root 3. Now we'll talk about whether we need to rationalize that in a moment, but the next thing we need to address is the complex fraction. Now remember, when you have a complex fraction, we can write that a little bit differently. Dividing by a fraction is the same as multiplying by its reciprocal, just like so. Remember, root 2 is really over 1 if you think about it that way. And so when I simplify that and I multiply those together, that's actually going to give me the square root of 6, that's 2 times 3, over 2. All right, now, if it is all possible in this problem, we want to try to get a common denominator. So this is where we're going to utilize some of our Algebra 2 knowledge of working with radical expressions. So in this situation, I think it's best for us to get the common denominator by simply multiplying the other fraction by the other's denominator. What I mean by that is for the 3 root 3, I'm going to multiply it by 2 over 2. And then for the other root 6 over 2, I would multiply it by root 3 over root 3. Because by doing that, we now have that common denominator. We can now write this as 6 plus the square root of 18. That's what 6 times 3 is. And now the common denominator here is 2 root 3. Okay, the only other thing we could probably do in this situation to wrap this and make this as simplified as possible is recognize that the square root of 18 can indeed be simplified because it's 9 times 2, 3 times 3. So that means that my final, and I would say most simplified answer would be 3 root 2, so 6 plus 3 root 2, over 2 square root of 3. And that would be our simplified answer. If we wanted to rationalize, we absolutely could. And again, if there was a need for that, we would just multiply both top and bottom by root 3. That would be the only thing you would need to do to find an answer. And actually, let's go ahead, since I have a moment here, to show you that if you're interested in seeing it. So if I wanted to rationalize this, if there was a need to, we would multiply top and bottom by root 3 over root 3. What that's going to do is in my numerator, we would distribute, so it'd be 6 root 3 plus 3 root 6 over, and then this would become 2 times 3, or 6. So what you might actually notice here is we could actually pull out some numbers to simplify this. We could pull a 3 out of the numerator, like so, and that's going to cancel this out and make it 2. And so our rationalized answer, an equivalent form essentially, would look like this. Again, which one is the better answer in this situation? Well, we don't really need to worry about that because we're not worried about using these in other contexts. So for right now, make sure you know how to rationalize, but know that you can leave a radical in your denominator. All right, well, that will conclude this video. You now have your own practice here on the next page for you to walk through and try this out yourself. Best of luck, and I hope you have a good rest of your day.